Hello, so you know how I said that we were done with exponents? Well, we're going to use them now to explore roots and square roots specifically today, but let's go ahead and jump into it. So we have special names for these exponents when it comes to 2 and 3. So for example, here, sorry about that, this exponent can be read a certain way. We know it can be read as x to the power of 2, but the new way that I want you guys to focus on is that this could also be read as x squared. So let me give you another example. If I looked at this right here, how do you think I could read this as? Hopefully you said something as 3 squared. Let me give you another shot. Let's look at this. How do you think you can read this? Hopefully you said it can be read as -4 squared. Okay, so notice how this 2 can be read as squared. And we're going to be talking more about why the name squared, but I just also want to quickly show you guys that this exponent of 3 also can be read in a different way, or a special way. It could be read as x cubed. And we usually typically read this as x to the power of 3. So I'm just going to give you a few examples. 4 to the power of 3 can now be read as 4 cubed. And -2 to the power of 3 can now be read as -2 cubed. Okay, so notice how these are just special names we give them. Okay, so why the name squared? Well, let's look at that word squared. What word do you see in the word square? I see the word square. So what do we know about squares? Well, they all have the same sides. So all their sides are the same. So let's just look at this example here. I have this square and all its sides are 4. And let's say I want to find the area. But how do I find the area of a square? Well, hopefully you know by now that it's length times width. So to find the area, I would have to do 4 times 4. How could I write 4 times 4 as an exponent? I can write it as 4 squared. And 4 squared is equal to what? 16. Awesome. Let's go ahead and look at another example. Let's say I want to find now the area of this square. So let me grab my marker. So 3 times 3. I can rewrite that as 3 squared, which is equal to 9. So now let's look at the answers we got. And there's something special about the answers 16 and 9. They're what we call perfect squares. And a perfect square is a number that can be made by multiplying a whole number by itself. So both of these, 16 and 9, are perfect squares. So let's look at the definition again. I need to find a number that when I multiply it by itself gives me 16. Well, I already know that 4 times 4 is going to give me 16. But guess what? There's another number that when I multiply it by itself, it's going to give me 16. See if you can figure it out. Did you guess it? It's -4 and -4. Remember, they have to be the same number. So -4 times -4 gives me positive 16 because a negative times a negative is positive. All right, let's look at 9. What number times itself is going to give me 9? Do you already know? Most likely said 3. But just like 16, it has 2 answers. So what number now times itself is going to give me 9. Hopefully you came up with -3 and -3. So how does this relate to roots? Well, some of you have already seen the symbol, and this symbol right here is what we called a root symbol or a radical. And although it kind of looks like the division symbol, this is not the same as division. And a lot of students confuse it because they kind of do look similar, but the root symbol has this little check mark thing at the front. So these two are not the same, and I'm actually going to go ahead and cross that out. So please do not confuse this as division. And there's a special type of root symbol. Some root symbols have numbers here, right, like above the little part that looks like a check mark, and that changes its meaning. But for right now, we're only going to be looking at this symbol with no number. And this is what we call a square root. Okay, so let's look at an example because it makes more sense. So let's say I have this problem, and this problem is read as the square root of 16. So what is this asking us to do? Well, it's asking us what number times itself is 16. Well, from beforehand, we already know that 4 times 4 is 16, and -4 times -4 is 16. So, my answer to this, the square root of 16, what number times itself gives me 16? Well, 4 and -4. So we have two answers. And I'm actually going to show you a shorthand way of writing this. So the square root of 16, I can write my answers as plus or minus 4. And this is just telling the person who's reading my work that the answer is both +4 and -4. Okay, let's try to do some on your own. Example 1. So what is the square root of 4? What's the square root of 4? What number times itself is going to give me 4? Some of you might have said 2 times 2 is 4. Awesome job. That's totally correct. What other number times itself is going to give me 4? -2 times -2 is also going to give me 4, because a negative times a negative is a positive. So my answer here is the square root of 4 equals 2 and -2, or I can write it in my shorthand way, plus or minus 2. Up to you, whatever you feel more comfortable with. All right, let's look at another example, and I'm going to pick a different color. So square root of 25. Okay, so how do I find the square root of 25? Once again, I ask myself, what number times itself gives me 25? Hopefully you know 5. And which other one? And -5. Because 5 times 5 is 25, and -5 times -5 is also 25. So my answer here is plus or minus 5. So either way you write it, they're both correct. Last example, example number 3. Pick a different color. What do you guys think? All right, I'm just going to give it to you. Hopefully you got both of these answers. Plus or minus 3, meaning +3 and -3. All right, so I want us to look at this multiplication table, because all along in these multiplication tables, perfect squares were hidden within. So I'm just going to grab my black marker and show you. 1 here is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. And you can keep going. All of these here down the diagonal are perfect squares. And we're going to be testing your ability tomorrow to find their square roots. So what do you think the square root of 81 is? What numbers times itself give me 81? Hopefully you said 9 and -9. All right, guys. I know it's a lot to take in, but don't worry if you don't feel you got it all the way. That's okay. We're going to be practicing tomorrow. All right? Have a great